So here's a note on exercise 5.27. In this case, we have a function of three variables. So f is of x1, x2, x3. Its PDF is joint PDF is 1 plus x1 plus x2 plus x3 to the fourth, and for all xi greater than 0, and then 0 everywhere else. So what they would like to do is just the sum. So they've got y is x1 plus x2 plus x3, and they would like you to find the PDF of y. So again, you go through that same thing, fyy, that's the probability that y is less than or equal to little y, but that's just the probability that x1 plus x2 plus x3 is less than or equal to little y. Well, this is not so obvious to draw, really, but it works the same way as what we had with the x1 plus x2 is less than or equal to y. Pretty much, what I would suggest is that you allow x1 to go from 0 to y, right? Forget the other two, right? Get rid of those, and you just have x1. Well, it has to be greater than or equal to 0, and it could get as big as y. Okay, so let me get those back. Plus x2 plus x3. But then you see, once you've picked x1 that's somewhere in between 0 and y, you're going to allow x2 to be anything from 0 to y minus x1. Okay, because it can't, the two of them, x1 plus x2, can't be any bigger than y. And so we have that, and then of course now we allow x3 to go between 0 and y minus x1 minus x2 is how big it could get. And so now we would then have that our fy of y is this integral from 0 to y, and then an integral from 0 to y minus x1, and then an integral from y, from 0, try that again, from 0 to y minus x1 minus x2 of our 6 over 1 plus x1 plus x2 plus x3 all to the fourth, dx3, dx2, dx1. So really, in that way, it's pretty straightforward to get your CDF. And then once you get that, you get your PDF. Now, I say it's straightforward. It's straightforward to write this down, from all this. But, yeah, this integral gets a little hairy. It's simplified. The answer is in the back of the book for little f of y. So, this simplifies down nicely, but it's kind of a nasty thing to work with by hand. And I tried it with Sage, and what I found was Sage Math will give me the right answer. I have to do a lot of the assume stuff. I had maybe 5 or 6 assume statements by the time I was done. But you know, it will do this integration just fine, and it gives a correct answer in the sense that if you plot it and you plot the answer in the back of the text, they are exactly the same curve, but it doesn't look the same. And you can kind of see how you could probably simplify and so forth, you know, and how that would work. But this one, you know, it is a mess once you get to here. So you get to here and you do this integration. It's pretty messy, but it is doable. And so you just want to take your time on doing that. Mostly, you know, just kind of think about how this became these bounds here. So pretty straightforward bounds and why we did it, right? We just said, hey, let's pick them one at a time. The outside one we'll pick as x1. So we did that one last. And then, you know, once we picked x1, then we went with x2. And then once we picked x1 and x2, then we got the bound for x3. So there you go. That's kind of an intro to exercise 27.